Good afternoon. Um, Today we are going to do harmonic analysis. And, we are going to work on one example after we cover that. So it's part of signal processing. Any question before we start? We are doing harmonic analysis for periodic motion which they are not harmonic. So it should be a periodic motion is the motion which is going to repeat itself regularly. So harmonic motion are the periodic motion which they are either sine or cosine function. So we are gonna express the periodic motion as an infinite summation of sine and cosine terms, and we call it harmonic analysis. So x of t, for example, if suppose x is a periodic motion, as you see, it's going to repeat itself over the time. We would like to represent this as a summation of some harmonic function, a2 cosine of 2 omega t plus b2 sine of 2 omega t it's a constant part, coefficient of a1 times cosine of 1 omega t, b1 sine of 1 omega t. This term is a2 cosine of 2 omega t and b2 sine of 2 omega t. So you are going to have the term with 3 omega t, 4 omega t, up to n omega t, and n goes to the infinite values. And omega is 2 pi over t. What would be the value for the t? It's a period of oscillation for the periodic motion that we have. So we know omega. We are going to find a naught, a1, b1 to a to bn. So I can, if I rewrite this again in a sigma form, it's going to be summation of I, is it I? N goes from 1 to infinite value of an cosine of n omega t plus bn sine of n omega t. So this is going to be the same as this one. Good. So the harmonic analysis, in harmonic analysis we are trying to find the coefficients a naught, a1, b1, a2, b2, a3, b3 up to a and bn, such that this function represents this periodic motion. Why we are doing this? Because dealing with a harmonic function, it's much easier than not harmonic function. So this is a non-harmonic because it's not a sine and cosine. We are gonna have a function as a summation of some harmonic function. So I'm gonna start with a naught. How can we find a naught? I multiply both sides we integrate both sides from 0 to t, which is this, for both sides. The integration of x of t dt from 0 to t is going to be the integration of 0 to t a naught divided by 2 dt plus integration of cosine of n omega t dt plus integration of 0 to t sine of n omega t dt. So as a class activity, we are gonna do many integration today, and you are do the integration for this and this one. I'll do the third one. So do the integration of 0 to t a naught over 2 dt and the integration. Other? This is this one. This guy and this one. Question about this. A, N, and B. All right, number 13. Would you come to the board and do the integration for this one? You can do that one. So what we are doing in harmonic analysis, we are trying to find the coefficients. So by multiplying x, by doing the integration, I'm trying to find a naught. T is noun, so omega is not noun, so as you leave it with capital T. So you don't need to plug into I over omega. Just leave it with capital T. Thank you. Would you let me ask someone for the second part. Number 6.
Yeah, I didn't finish it yet.
Did you try this? Number 8. Usual.
The one with the
With cosine.
cosine.
We just want to see what would be your approach, and if there is any difficulty, it's time to use this part.
So, the problem I was having, I was trying to figure out what exactly is between that vertical.
We are an is constant. It's not changing with time. Okay. So the only thing which is varying with time is this guy, cosine of n omega t dt. So what we are looking basically is the integration of an. We can use this part, cosine of n omega n t dt from 0 to capital T.
So, the only thing that's changing is
Just time. The n is constant, omega. It's n omega, not omega n. Thank you. Any different thought? We had negative an sine of n omega times t, negative an sine of n omega times 0. Do you want to change any? An is constant. Only term which is varying with time is cosine of n omega. You can write here. Thank you. So the integration of an cosine of n omega t dt. This is constant, it's coming out of the integration. The derivative of cosine of n omega t would be sine of n omega t divided by whatever is the coefficient of time, which is n omega. So it's going to be an divided by n omega times sine of n omega t, and time goes from 0 to capital T. Good? You had negative, but derivative of sine is going to be cosine. We don't need to have negatives here. And you forgot about this coefficient. When you differentiate this, you will get n omega coming out of the derivative. It should have n divided by...
Constant that is not going to be altered because it's a constant.
The constant is this guy. Also, this one is constant, but when you differentiate this, you should get inside the integration. When I differentiate that, I will get n omega as a coefficient of time. It's coming out of the derivative. You should have n omega here. You can cancel them out with that one. Is that clear?
Would you neglect the zeros since sine is 0 to 0? So
Yes, this is the next step. So now I'm gonna plug in capital T and 0 here. It's gonna be an divided by n omega sine of n omega times capital T minus an divided by n omega sine of n omega times 0. N omega times 0 is going to be 0. Sine of 0, no matter what would be the n omega times 0 is going to be 0. Sine of 0 is going to be 0. Here, sine of n omega times capital T. Omega is 2 pi over capital T times T. So n omega times T. We can cancel out these two T, so we'll get sine of n multiplied by 2 pi. No matter what would be the value for n, either 1, 2, 3, 4, sine of any coefficient of 2 pi is going to be 0. Because sine of 2 pi is 0, 4 pi, 6 pi, 8 pi. So this term is going to be 0. Good? Sine of 2 pi is 0, sine of 4 pi equals to 0, sine of 8 pi, so n, for any n, assume n equals to 1, you will get sine of 2 pi. Equals to 2, you will get sine of 4 pi. 3, you will get sine of 6 pi. For any terms, you will get this term equals to 0. So you will get this part of integration equals to 0. Question on this. Is that clear? So I'll do this part. The integration of Bn sine of n omega t dt. Bn is constant, is coming out of integration. Integration of sine of n omega t, it's going to be negative cosine of n omega t divided by n omega. Good? Derivative, if you differentiate cosine, it's going to be negative sine. That negative can be cancelled out by this. It's going to change to the positive. Sine of n omega times n omega, this n omega can be cancelled out with that coefficient. We will get Bn sine of n omega t. Now I'm going to plug in time here. For this one, I will get negative Bn divided by negative Bn divided by n omega cosine of n omega t minus, we have two minus, it's gonna be positive. Positive Bn cosine of n omega times 0 divided by n omega. Is that clear? The reason that I'm asking you because we are gonna when I move on to finding the coefficient of A1, B1, it's gonna be more complicated, and we are gonna use this information, this approach. So let's look at this. Cosine of n omega capital T is omega is 2 pi over t. Cosine of n 2 pi over t times t. I can cancel out these two t, so I will get cosine of n 2 pi. Cosine of 2 pi is 1. Cosine of 4 pi is 1. This is the circle. 2 pi is this. 4 pi is this. 6 pi is this. So all representing the angle of 0 or 2 pi. And cosine of 0 or cosine of 2 pi is 1. So it's gonna be cosine of this is gonna be positive 1. It has one negative here, so I will get negative Bn n omega times 1. And here, cosine of n omega times 0, it's gonna be 1 positive Bn divided by n omega, negative Bn n omega divided by n omega, you will get 0. So these two integration, they are going to get the value of 0. So what is left? Question on this. What is left is going to be integration of this, integration of x of t dt, 0 to t, would be equals to a naught divided by 2 times capital T. So we are looking for a naught. A naught would be 2 divided by period of oscillation and an integration of x of t dt from 0 to capital T. So if you want to find coefficient of a naught, what you need to do, you need to go to the original function, do the integration of x of t, find the area. Find the area below the first period of oscillation, and that area divided, it's going to give you this integration multiplied by 2 divided by period of oscillation, you will get the a naught. One of the homeworks too, for homework, for the next homework which is going to do next Wednesday, you need to do the same things. So do the harmonic analysis for a given periodic function. Any questions so far? Is that clear? All right. Let's move on. The next coefficient, which is A1. So I'm done with A0. For A1 has the coefficient of has the term of cosine of omega t. I multiply both sides by cosine of omega t and do the integration from 0 to t. The integration from 0 to t, cosine of 1 omega t dt x of t dt plus equals to integration of 0 to t a naught divided by 2 cosine of omega t dt plus integration of from 0 to t a1 cosine of omega t dt this step plus integration of 0 to t b1 cosine of omega t times sine of omega t dt plus integration of 0 to t an cosine of omega t cosine of n omega t dt. And last term is cosine of omega t sine of n omega t dt. So what I did, I multiplied both sides by cosine of omega t, and then I applied the integration. So we can prove, it's not difficult, but we can prove that the integration of cosine of n omega t cosine of m omega t, this integration, n is different than m or they can be the same. It's gonna be equals to 0 for any m which is not equals to n. So if m and n are different, we can show that this integration is going to have the value of the 0. But if they are the same, if they are 2, if they are 1, this integration is going to be equals to capital T divided by 2. Also, we can, for sine function, sine of n omega t times sine of m omega t dt, it's going to be 0 for any m which is not equals to n, and it's going to be t over 2 for m equals to n. And from 0 to t of cosine of n omega t sine of m omega t is always equals to 0. Cosine, sine. Good. I used to have to drive this tree integration in the class, but just to save the time, I'm saying that we can prove that this integration is going to be equal to 0, t over 2, 0, t over 2, and 0 for the third one. Now let's look at right side. This is the coefficient. So I'm gonna have a naught divided by 2 integration of cosine of omega t dt from 0 to t. What's gonna be the value for this? It's not there. I mean, we just did it when I was going to drive a naught. We did the calculation for this integration of cosine of omega t dt. And what was the result after we plugged in 0 and t? 0. We did it right here. I did it. So if you doubt, it's going to be a naught divided by 2. Derivative integration of cosine of omega t is going to be sine of omega t divided by omega from 0 to t. So a naught divided by 2 sine of omega is 2 pi divided by t times t minus sine of 0, which is 0. Sine of 2 pi is going to be 0, so the entire of this term is going to be 0. This one, a1 cosine omega t cosine omega t. What would be the integration of second term?
Zero.
No,
A1,
n and m are the same. Both are 1, 1, 1. So it's going to be t over 2. So this integration is going to be, I have one a1 t over 2. But the rest, cosine of 1 omega t, sine of omega t. Third row, cosine of n omega, sine of m omega. No matter what will be the n and m, it's going to be 0. an cosine of omega t, cosine of n omega t. Here, n is 1, m is n. So 1 is not equal to m, it's going to be 0. So all terms would be 0 except this one. So left side is gonna give me 0 to t integration of cosine of omega t x of t dt equals to 0, 0, 0, 0 except this one. a1 times t over 2. I'm looking for a1. a1 would be 2 over t integration from 0 to t of cosine of omega t x of t dt. This is how I can find a1. How can I get a2? If I want to do the same things, what should I write for a2? For a1, I multiplied by cosine of omega t. For a2, I should multiply by cosine of 2 omega t. So what I'm going to get for a2? Just make say it again. a1 over a2. We are looking for a2. What do you think we can have for coefficient of a2? If you compare a1 with a2, right, I have a1. How can I write the expression for a2? Say it again. 4 over t. No.
It'll still be 2, but it'll be cosine 2 omega t inside it.
Just the same thing, except this cosine of omega t, it's gonna be 2 omega t. See, I just change this 2 omega, 2 omega, 2 omega, this term is going to be 2 omega. This term is going to be 0 because this is 2, this is 1. M and N are not the same. But the term which has A2 has cosine of 2 omega. I multiply by another cosine of 2 omega. I will get this one. So same as A1, it's going to be, we are going to get this time A2 times T over 2. So 2T from 0 to capital C, cosine of 2 omega T, x of T, dt. Good? Same thing for A4, for A3, sorry. A3 would be 2 over T integration of cosine of 3 omega T, x of T, dt. So to generalize that, I'm going to change A1 to AN for any A, no matter what would be the N. I should do this integration, 2 over T, 0 to T, cosine of N omega T, x of T, dt. It's going to give me AN, whatever is the N, I can get that coefficient by implementing this integration. Good. Now I'm gonna find the B terms. I'm done with A naught. I'm done with A terms. I need to find B terms. So it's for this I'm gonna multiply by sine of omega T. I'm looking for B1. I multiply both sides by sine of omega T, A naught divided by 2 dt. Yeah, A naught divided by 2 times sine of omega T. A1 sine of omega T, cosine of omega T dt. Plus 0 to T B1 sine of omega T sine of omega T dt plus integration from 0 to T A2 sine of omega T cosine of 2 omega T dt plus integration of 0 to T B2 sine of omega T sine of 2 omega T. And it continues until the last term, which is n. I will start with this. We just did it on the previous example. A naught is constant, A naught divided by 2. The integration of sine of omega, it's going to be negative cosine of omega T divided by omega. If I plug in T, I will get 1 minus 1, which is 0. So this integration, it's going to be 0. Second integration has sine times cosine. Both are omega. Sine of n omega, sine of sine of n omega, cosine of m omega. So no matter what would be m and n, this integration is always equals to 0. And a1 is constant. b1 is constant, is coming out of the integration. Sine of omega, just this one. Sine of n omega, sine of m omega, where we have those terms equals to each other, we will get b1 t over 2. This term has sine of 1 omega, cosine of 2 omega. It's always 0. This is sine of omega, sine of 2 omega. It's 0. So the rest of the terms are 0. So I will get b1 t over 2 equals to this integration. So I can write b1 equals to 2 over t integration 0 to t sine of omega t x of t dt is gonna give me b1. If I want to generalize that, I change 1 to n, same approach, sine of n omega t x of t dt, integration from 0 to t, I will get any question on this? I'm gonna work on one example, but is the approach clear? How did we derive the coefficient? Alright, suppose we have a periodic function like this. This is x, the function, this is t. From when time is 0 to pi, the x value has the value of negative k. K is the value. So, and from the time of pi to 2 pi, it's going to be positive k. Again, it's going to repeat itself. Three pi, 4 pi. So this is the periodic function that we have. This is one cycle, then it's gonna repeat itself. Good? It's a periodic function, true, because the motion, it's gonna repeat itself over the time. From 0 to pi, it's get the negative k, from pi to 2 pi, it's get positive k. Then again, from 2 pi to 3 pi, negative k, from 3 pi to 4 pi, positive k. And we are gonna have the same pattern over there. So it's a non-harmonic but periodic motion. So we can apply the harmonic analysis. I would like to write this function as a summation of harmonic function or sine or cosine. So if I want to write the mathematical form of this function, x of t is gonna get the value of negative k when time is between 0 to pi. And it's getting positive k when time is between pi and 2 pi. Since it's a periodic function, it should have period of oscillation. What would be the period of oscillation for this? 2 pi. It's gonna repeat itself after 2 pi. 2 pi. At any point that you will get, if you add it to 2 pi, you will get the same things. So capital T is 2 pi. So I can find omega right away. Omega is always, it's just definition. 2 pi divided by t. T is 2 pi, so it's going to be 1. Omega is 1. So let me start with A naught, the first one. I should do this integration. 2 over capital T, which is 2 pi. Time goes from 0 to 2 pi. X of t dt. Okay? This is how I can find A naught. I have the mathematical format of the function. I should be able to implement this integration. Everybody can see how I write this. Alright, but what would be the value of or function of x of t? Depending on the time, we get two values. So I should break the integration from 0 to pi, which is this, plus pi to 2 pi, which is get this value. So 2 over 2 pi is going to be 1 over pi. Integration from 0 to pi, I should break it from 0 to pi, x of t dt plus integration from pi to 2 pi, x of t dt. So A naught would be 1 over pi. The first integration, x of t is going to get the value of negative k. Integration of 0 to pi, negative k dt plus from pi to 2 pi, in this period of time, x of t has a value of positive k. Any question on this? So far. Alright, k is constant. I can say 1 over pi negative, this integration is going to be negative k times t. The integration is going to be negative k times t. If I differentiate this, I will get negative k. And t goes from 0 to pi. Plus, this is going to get the positive k, t goes from pi to 2 pi. So 1 over pi negative k times pi, negative k minus is going to be positive k times 0. Positive k times 2 pi, negative k times pi. Minus negative k times t is pi. So negative k times pi, negative k times pi, negative 2k times pi. Negative 2k times pi plus negative plus 2k pi, it's going to be 0. And this is going to be 0. So inside the bracket is going to be 0. 0 divided by pi is going to be 0. So we don't have any constant term for A naught. Any question on this? So let me look at AN. AN, how can I find AN? 2 over 2 pi, sorry. 2 over 2 pi. Integration from 0 to 2 pi. Cosine of n omega t, just whatever. And omega is 1, nt, omega is 1, nt x of t dt. I need to find this integration. Again, x of t has two values on the in one cycle. So I should break it to two periods of time. 2 over 2 pi and 1 over pi. Integration from 0 to pi cosine of nt. X of t get the value of negative k dt plus integration from pi to 2 pi cosine of nt positive k dt. Why did I break it to two periods? Because the original function has two values over the cycle. K is constant. I should just be worried about cosine of nt dt. So it's gonna be 1 over pi. Negative k is coming out of the integration. The first integration of cosine of nt dt, it's gonna be sine of nt divided by n. Just differentiate this. If you differentiate this, it's gonna be cosine of nt times n. You cancel out n and you will get cosine of nt. And it goes from 0 to t. Second one, k is coming out of the integration. The integration of cosine of nt is going to be the same sine of nt divided by n. Time goes from t to 0. Any questions so far? Yes,
Why did it go back to being 0 to t in the evaluation?
it should be pi. Thank you.
Pi.
Yes. And pi to 2 pi. Because the period of integration is 0 to pi and pi. So let me plug in the term negative k sine of n pi divided by n minus sine of n times 0 divided by n plus k times sine of n is there, t is going to be 2 pi. 2 pi n divided by n minus sine of pi times n divided by n.
You
Good.
get the 1 over pi.
At
You
least
got the 1 over pi.
1 over.
So,
Constant.
Oh yeah, thank you. Yes, I missed. Yes. So what will be this value? Sine of n pi? Zero. Just think. Sine of pi, 2 pi, 3 pi, 4 pi, any pi, it's gonna have 0. Sine of 0 is always 0. So negative k times this is gonna be 0. Look at this. Sine of 2 pi times n. N is 1, 2, 3. Since it's a coefficient of 2 pi, this is 0. Sine of n pi, same thing, it's gonna be 0. So the entire of this is gonna be 0. 0 divided by pi would be 0. So we don't have any cosine term. A1, A2, A3, A4, A4, A5, all terms would be 0. Any question so far? Alright, the last term, Bn cannot be 0 because if it's 0, it means all terms in the harmonic, in the Fourier series, they get the value of the 0, but we know that the x is changing with time, so it cannot have value of the 0 for at least some of the b values. So Bn is gonna be same things, 2 over 2 pi, it's gonna be 1 over pi. 2 over 2 pi is gonna be 1 over pi. Integration from 0 to pi, I'm gonna break it, instead of having 0 to 2 pi, I'm gonna break it to 0 to pi, pi to 2 pi. 0 to pi sine of n omega t, omega is 1, so nt, x of t from 0 to pi is negative k, dt plus integration from pi to 2 pi sine of nt times positive k dt. So negative k is constant, is coming out of the integration. But sine of the integration of sine of nt dt n is constant, is gonna be negative cosine of nt divided by n. So it's gonna be negative k times negative cosine of nt divided by n. Time goes from 0 to pi. Plus second integration is going to be positive k, negative cosine of nt divided by n. Time goes from pi to 2 pi. Good? Here we have negative k times this divided by n. Second term is positive k times negative cosine of nt divided by n. So I can take k over n out of these two terms. So I'm gonna write one more time. K over n pi. K over n pi. This negative times this is gonna be positive. So I will get cosine of nt goes from 0 to pi, but this is gonna have the negative value, negative cosine of nt from pi to 2 pi. So k over n pi, I'm just plugging the values here. Cosine of n t is pi minus cosine of n times 0 minus cosine of n times 2 pi minus times minus is going to be positive. Positive cosine of n times pi. Good? Everybody can see how I plug in pi and 0, 2 pi and pi in these two terms. Cosine of n times 0, it's going to be cosine of 0. And cosine of 0 is always 1. So this one is going to be negative 1. Positive times negative coefficient, you will get negative 1. N times 2 pi. No matter what would be the value of the n, cosine of, if n is 1, you will get cosine of 2 pi equals to 1. Cosine of 6 pi, if n is 2, you will get cosine of 4 pi. Again, it's going to be 1. So for any value of the pi, you will get positive 1. So if I rewrite this again, k over n pi, this cosine of n pi plus cosine of n pi, I will get 2 cosine of n pi. Minus 2. Now, if n is 1, what would be the value? Cosine of pi for n equals to 1 is going to be negative 1. Negative 1 times 2, negative 2. Negative 2 minus 2, it's going to be negative 4. So for n equals to 1, Bn would be 4 over n pi times negative 4. Right? For n equals to 2, cosine of 2 pi is positive 1. Positive 2, 2 minus 2, 0. N equals to 3, odd number. Cosine of 3 pi, negative 1. Negative 1 times 2, negative 2. Negative 2 plus negative 2, negative 4. So for any odd values of n, Bn would be this. For even number, Bn it's going to be 0. Good? Any question about this? So if I ask you to write the Fourier series of the original function as a term of sine and cosine, you can write this function that you have seen, that you have over there, can be written as x of t equals to a naught divided by 2. A naught we got 0, so I don't need to be worried about that. A1 cosine of omega t, all a values are 0. This term, B1, just plug in n equals to 1. It's going to be k divided by 1 times pi times negative 4. Negative 4k divided by pi sine of omega t plus A2, A is 0. B2, n b2 n is even number, b2 is gonna be 0. So this term is gonna be 0. a3, this is 3, this is 3 omega. All a values are 0, so I should look at b3. b3 is gonna be b3 times sine of 3 omega t. N is 3, k divided by 3 pi times negative 4. Negative 4k divided by 3 pi sine of 3 omega t plus negative 4k 3, the next term that it's going to show up here is going to be 5. 5 pi sine of 5 omega t. And omega was 1. So continue. It can continue to infinite terms. So negative, if I ask you to draw this function as a with Fourier series on MATLAB, you can, suppose k value is given, k is 4, 5, whatever is the value. You can draw this function, this periodic function, as a summation of harmonic functions. See, all terms are sine or cosine. We don't have any cosine, all terms are in sine terms. And depending on the accuracy that you are looking for, you may need to have 2 terms, 3 terms, more or less. So in the homework problem, I asked you to plot this this function with 3 terms, I guess. And the function that you will get, it's very close to the original function. So after you figure out these terms, you replace the original function with this one, and now you have harmonic function. You have harmonic function, you shouldn't be worried about derivative, differentiation, or integration. And this is something that the people are doing in signal processing. Any question so far? It looks like a long process, but
Will we ever get a periodic function that's not piecewise?
this is not.
Piecewise, that's not, multiple different things depending on time. It's a continuous function but not harmonic.
Yeah, just like this. It's a, suppose it's a half circle or parts of a circle. Just repeat that. Any question? Any other question? Let's look at this before we finish today class. So this is the harmonic function. This is the periodic function that we have. Like this motion is gonna repeat itself over the time. This is the actual function, like this. If we do the harmonic analysis, we get the coefficients, different terms for the Fourier series. If we just look at the first term, one term approximation, just A naught. If we do that, this function is gonna look like this line. A naught is gonna be A over, A naught is gonna be A naught over 2 is gonna be A over 2. So if you want to represent the original function with the only first term, this is what you have, which is too far from the original function. If you consider 2-term approximation, you consider A naught and second term. Second term, I mean second term which is not 0. Then it's gonna look like this. It's much better than the first term, but we still have some difference compared with the original function. 3-term has more accurate approximation than the first 2 terms, than the 2-term approximation. So if you want to have more accurate, you should have 4-term approximation. As you see, this 3-term, it's very close to the original function, which is not harmonic function. So now you can use 3-term, or if you want to have more accurate, 4-term approximation and deal with that. Is this clear why we are doing this? We switch from original function to the harmonic function, which they are sine and or cosine functions. Alright, we'll stop here. I'll collect the homework 1 and we continue on next Monday.